Hello and welcome to a video on rational functions, and we're going to look at most of the process of analyzing a rational function in this video. The only thing we're not going to talk about is end behavior. So this video has x-intercepts, y-intercepts, vertical asymptotes, holes, all of that will be talked about in this video, all coming from the equation. So the first thing we want to do is we want to look at the steps here. And these steps, order matters in these steps because the holes really need to be canceled out before anything else if they exist. So the steps, first factor, if it's not already factored, reduce it to lowest terms, and notice that when you reduce something, you're looking at holes when you have to reduce. So that's steps 2 and 3 are all about the holes. If there's no holes, there is no step 2 and 3. And then whatever is left in the numerator is going to give you intercepts, x-intercepts. The denominator will give you vertical asymptotes once you cancel out for holes. And the y-intercept you find the same way you always find it, by setting x equal to 0. So we're going to look at 3 types of examples here. First, we're going to look at an example that has no holes, and therefore and nothing to factor. It's already factored. So you don't really have to worry about steps 1, 2, and 3 in the first example. The second example does need to be factored, but there's still no holes, so no steps 2 and 3. And the third example is going to have everything that we can have as far as all of the steps in this process will be there. All right, so let's look at the first one where everything is already factored, so we really don't have to worry about step 1. There's nothing to reduce in either one of these examples, and so we're going to go right on to step 4 and get the numerator gives us the x-intercepts, because whenever the numerator is 0, that makes the whole thing 0. So the x-intercepts come from setting 5x squared equal to 0, which means pretty much just x equals 0. And the zeros in the denominator give you the vertical asymptotes. So 3 plus x equals 0, or x equals negative 3, there's your vertical asymptote. So we've got vertical asymptotes, we've got our zeros or x-intercepts, and now the only other thing is to find the y-intercept, which is to find r of 0. And r of 0 is 0 over 3, which is also 0. So the y-intercept of this one is 0. Okay, this is the x-intercept. Okay, let's look at the next example. Also already factored, also nothing to cancel. So we're going to go ahead and look at the numerator for x-intercepts. So x-intercepts come from x minus 3 equals 0, or x equals 3. That's the only x-intercept. Vertical asymptotes come from, we'll just say VA here for vertical asymptotes, come from setting the 2 factors. There's 2 vertical asymptotes in this one. X plus 2 equals 0, which means x equals negative 2, that's 1. And the other one would be x minus 2 equals 0, x equals positive 2, that's the other vertical asymptote. And then to find the y-intercept, you just find h of 0, which would be negative 3 over 2 times negative 2. I just made all the x's 0, so they pretty much disappear. And that is negative 3 over negative 4, or 3/4. There's your y-intercept. All right, let's get to the to one that requires factoring. So these two are not factored, so let's start out by factoring this first one. So we're going to write x squared plus 2x minus 15 as a set of 2 factors, and that's going to be x, and 3 and 5 will work, so we'll put 3 and 5, and it's going to be minus 3 plus 5. And then in the denominator, it's going to be x plus 2 times x minus 2. And then, other than that, the process is exactly the same. So as far as our x-intercepts, they're going to come from the numerator. So we have x minus 3 equals 0, which means x equals 3, that's 1. X plus 5 equals 0, which means x equals negative 5, that's 2. There's our x-intercepts. All right, vertical asymptotes come from the denominator, so x plus 2 equals 0, or x equals negative 2, that's one vertical asymptote. And x minus 2 equals 0, or x equals positive 2. So these are the two vertical asymptotes. And then the last thing here is just the y-intercept. So we're just going to find f of 0. This is the y-intercept. And f of 0, I'm just going to look back at this because it's easier. And all I have left there, if I make the x is 0, is just negative 15 over negative 4. Negative 15 over negative 4 reduces to just 15 over 4. There's our y-intercept. Okay? Let's look at the next example. So factor first, and then we'll go from there. So why don't we pause the video and see if you can factor it and find those 4 things. Okay, so our x-intercepts, first factor form. Our x-intercepts are based on the two things that make the numerator 0. Our vertical asymptotes are the equations that make the denominator 0. And our y-intercept, when we find f of 0, we get negative 4 over 0, which is undefined, so there is no y-intercept. All right, let's look at something now that requires all the steps. So we're going to start out the same way. In fact, anytime it's not factored, you're going to start out by factoring. So this would be x and an x, and plus 2 and plus 1. And in the denominator, it's a difference of squares, x plus 2 times x minus 2. All right, so for the first time now, we're seeing something that in factored form has the same factor, a common factor of x plus 2. So we want to reduce this, but the thing to keep in mind here is, and I'm going to write this here as just a sort of an asterisk. So here, we're going to say that x plus 2 over x plus 2 times x plus 1 over x minus 2 is not equal to x minus 1 over x minus 2. All right, it's not the same thing, and you need to keep that in mind when you do the cancellation. So it's because they're not the same thing, because in this equation, you can have x equals negative 2, and it's fine. In this equation, you can't have x equals negative 2. So they're not the same thing. And really that negative 2 is the only difference. So that's what we're going to do, is we're going to cancel the x plus 2, but we're going to keep in mind that x cannot be negative 2. That's going to be where the x coordinate of the whole is. So our new function is going to be g of x equals x minus 1 over x minus 2. But there's a hole at x equals negative 2. There's a hole where x plus 2 equals 0. This is where x plus 2 is 0. Okay? Now, having the x coordinate of the hole is not enough. What we need is we need both. So we need negative 2, and then what is the y coordinate? It's going to be what happens when we plug negative 2 into our reduced g of x. So that's going to be g of negative 2. Now, just going back to the directions at the beginning here, that's exactly what it says here. It says reduce the function to lowest terms. If the terms were canceled, the zeros of the canceled terms is or are, there could be more than one, the holes in the graph. Step 3, for each hole, if there are any, find the y coordinate by reducing the reduced function at the x value, at that x value. So that we've found this is the reduced function according to those directions. Okay, this is what we mean by the reduced function. It's been reduced, right? We've canceled out a term. So we need now to find g of negative 2. So g of negative 2 is going to be negative 2 minus 1 over negative 2 minus 2, which is negative 3 over negative 4, or 3/4. That's the y coordinate. So now we can say the whole is at negative 2 3/4. And when we get to the part where we're graphing this, we know exactly where to graph the whole. All right, that's pretty much what we need for steps 1, 2, and 3. Let me just circle that a little bit better so I'm not crossing it out. All right, now that we've got that, we have our reduced equation, and our reduced equation will give us the rest of what we need for the problem. So we're able to still get our x-intercepts now from the numerator. So that's where x minus 1 equals 0, or x equals 1. we're able to get our vertical asymptote. In this case, there's just one, where x minus 2 equals 0, or x equals 2. It's important to keep in mind, too, that this is a point. But this, being a vertical asymptote, this is actually an equation. Keep in mind, they look very similar to each other. They're different numbers, but they look like they're formatted the same thing, but they're really different things. All right, and then the last thing would be the y-intercept. So we can do this in the reduced equation. G of 0 would be 0 minus 1 over 0 minus 2, which is the y-intercept then would be 1/2. And there it is. We've got a whole for this one, x-intercept, y-intercept over here, and then the vertical asymptote. All right, let's try the next one. So why don't we pause the video and you guys give it a try. All right, so when we factored this numerator, it factored in one step, but the denominator took a second step. Once we factored that second step, we see a common factor of x minus 2. That indicates that there's a whole where x minus 2 equals 0, right? X minus 2 equals 0, that's where we got that. And that whole gives us also the reduced function. So the reduced function is right here in green. That's our new f of x. And that's what we're going to use for the rest of the problem, including finding the y value of the whole, the y coordinate of the whole. So I found f of 2 for that reduced function, and I got 7 over 12. And that's the y coordinate of the whole. So I have a whole where the x coordinate is 2, y coordinate is 7 over 12. X-intercept, I focused on the numerator of my reduced function, and I got negative 1/3. Vertical asymptote, I focused on the denominator of my reduced function. I got x equals negative 2. Y-intercept, I just used the reduced function to find f of 0, and I got 1/6. Okay, that's it. I hope you found this video helpful.